Well, you should actually technically, you can have notes on this already. But the thing of this is surface area of pyramids and cones. So much of this is just formulas. Surface area. And the little image there is of. Do they give us one for each of them? Yes. Surface area. First of all, starting with a right pyramid. And here's the formula, but you need to know what these letters all stand for. Two ways to write it is, I guess we'll do this. PS over 2. Or the book says another way to write that is 1/2 PS. Either way of those work. This is nice because then you can kind of cross cancel before you multiply if you want to. This one just kind of makes it multiply there. What is P? P is the perimeter of the base. And then S, which you'll never get, is the slant height. Usually in math when we talk about height, it's perpendicular to the base. Slant height is not that. It's the height of the slanted piece of the thing. So we have to draw one here, and I guess we should draw the one that they have in the book there.
Yeah.
I don't like it, so let's do it. What is that thing that looks like a
hexagon?
A hexagon. 1, 2, 3, 4, 5, 6. Put a little dot up here. 1, 2, 3, 4, 5, and 6. That doesn't look quite right. Eek. Not my best effort there. But it tells you the dimensions. It says find the lateral surface area of the right pyramid with a slant height of 10. Now note slant height would be this height right here. That is what is 10. Perpendicular height of the shape would have to be given as a dashed line that kind of goes right to the middle, or they would do it like this. That would be the regular height. But this is the slant height, which is what that little S stands for right there. And then the perimeter they also tell you is, regular hexagon. The base is a regular hexagon, and you must know that regular means
All sides are equal.
you do remember something. Regular hexagon whose sides are 5 centimeters. So, using the formula given there, we have to take the, surface area equals, what is the perimeter? If you had 5 6s or 6 5s, you add it all together. Your perimeter is going to be 30. The slant height, lucky you, they gave to you, which is 10, and that's all cut in half. Cut in half. And so it doesn't matter the order you do this, either way you slice it, you're going to come up with 150, whatever it is, centimeters squared. Should we go into why that is, or do you just want to accept it?
Why?
Well, why do you cut it? Let me ask you, do you think you have a reason? Do you think you can figure out why you cut it in half? What shape is every side?
Triangles.
What do you do with triangles? Cut them in half. And that's why it's half. Otherwise, if they weren't triangles, it would just be a regular prism, and it would be perimeter of the base times the height. That's the lateral surface area. Wait, is this lateral surface area, is it? Yeah, I should have put that down there. This is LSA, not total surface area. Lateral surface area. Make sure you get that. And then, one more lateral surface area. And that is of a cone. LSA of a cone. Guess what it's going to be?
2 pi r times s over 2.
It is going to be the same thing as the lateral surface area of a cylinder, except
It's not.
cut
It's
in half. Yeah.
pi RS.
2 pi r times s.
According to this, it's 2 pi r. Oh wait, why would we go with that? No, I'm sorry, it's just pi rs.
Yeah, we're good.
Pi times radius times slant height. That's all you need to know for that. This might actually come up on some sort of test somewhere, but I don't know. It's not total surface area, is it? No, it's lateral. So all you need to know is these two things, which kind of they have to give you, I think. So here's my cone. And it is, looks like this says it is 10 from here to here. It says it is 12 from here to here. And it is 13 from here to here. And one of these things is not like the other. Remember, if they tell you to leave it in terms of pi, you don't have to do anything except leave the little pi symbol there. If they say do it out to decimals, you have to substitute 3.14 into pi. Or what was the fraction? There's a fraction to it.
22/7.
22/7. Pi, what's the radius?
5.
What's the slant height?
13.
13. So it is 65 pi. In terms of pi, I'm not even going to do it out. Someday I'll let you use a calculator. 65 times 3.14. Did we actually do this lesson back in the day?
Yeah.
Yeah, you remember?
He did.
I threw away all my assignments, so.
That is a shame. Yeah. Look at page 667, will you please, in your book? Let's just talk about a couple of these things. Number 8. See if this jogs any of your memory there. Is this relation a function, yes or no? Do you remember talking about that when it talks about graphs?
I remember it.
When we talked about graphs, we talked about what was called the vertical line test.
Oh, yeah.
If you're given the picture of some sort of a graph of a line, let's say the line is this. That's your graph of something. When you talk about something being a function, you do the vertical line test, which just means you just think this. I'm going to draw as many vertical lines as I can through the graph. If the line does not cross, if my graph line only crosses every vertical line once, it is a function. This is a function. The thing they gave you in the book looks like the letter C. If you are doing the vertical line test, you can stop right there because this graph line crosses a vertical line in more than one point, and you can't have that with a function. So this is a big, fat, whopping negatory. No function. Vertical line test. Remember that? Does anybody remember that?
Yes.
What lesson did it come from? We would have done that on about May the 15th or 16th. It's only been 6 months and you forgot already.
I remember.
We've already talked about unions and intersections.
Yeah.
How about 16 and 17?
Are we doing this now?
We will be.
Oh, okay.
Unless we're doing all of it. See if this jogs your memory.
I remember this.
How about this?
I don't know.
I know some of you are comatose.
5, 10, 15.
Oh, I'm at 10.
If you were asked to multiply this, what would you get? 9 Now, your first thought generally is you get x squared plus 121, because 11 times 11 is 121. But if your memory banks go back, let's see, this was 92, so we'd be more along the lines of May the 6th or 7th. We had to do what we called what, Evelyn?
Foil.
Right, we had this little thing called FOIL. X minus 11 times x minus 11. That's what this is, because it's x minus 11 squared. Which meant you had to do what? The first terms times themselves, which is x times x. What is x times x?
Squared.
So you get an x squared. O is the two outside terms, which would be out and out. Negative 11 times x is negative 11x, right? Negative 11 times x. The inside terms, the two inside, that's what the letter I stands for, which is again another 11 times x, which is another 11x. And the L stands for the two last terms, which would be a negative 11 times a negative 11, which is positive 121. Now when you look at that, you can combine these two. These are like terms, so you can put those together and you get x squared minus 22x plus 121. I will probably review that again with you tomorrow. Actually, I may just give you a quiz today, and we won't have it anymore, because you've got such a stellar class today.
Wow.